The next few questions we have questions that deal with landing angles. This one deals with landing at a right angle. So landing at a right angle like this means that we only have velocity in the j direction. So we can say that the velocity in the x direction is equal to 0, or undefined slope, as s of y is equal to 0, v of x is equal to 0. So that's what's required here. So let's have a look at setting up this question. We've got initial speed u, angle alpha with the plane, and beta with the horizontal. So general diagram, beta with the acceleration attached, alpha, u going this way. So my initial vector is going to be u cos alpha in the I direction, plus u sine alpha in the j direction. My acceleration in the I direction is going to be minus g sine beta, and in the j direction minus g cos beta. My velocity in the x direction is equal to u plus at, u cos alpha, and plus a will be minus g sine beta times t. So we need to know the time taken to get there. We'll get that based on s of x being equal to 0, ut plus a half at squared is equal to 0. So my u sine alpha times t minus g cos beta times t squared, and the half, we'll put it over 2, equals 0. Factoring out our t, we get u sine alpha minus g cos beta times t over 2 equals to 0. So my initial t equals 0, or u sine alpha is equal to g cos beta times t over 2. So t becomes 2u sine alpha divided by g cos beta. If we put that into s of x, sorry, v of x being equal to 0, when s of y is equal to 0, we're going to get v of x is equal to u cos alpha minus g sine beta times 2u sine alpha over g cos beta. You see here sine beta over cos beta is going to give tan beta. So this is really where these questions go, and we're dealing with angles. We're looking at tan. V of x is equal to u cos alpha minus g tan beta, and I still have my 2u sine alpha. I'll just leave them in that order. 2u sine alpha. You can see the g's will cancel here. And if you see the sine a, we want tan a. If I divide this by cos a, we get tan a. So dividing both by cos a, I get, well, v of x is equal to 0. So I'm going to get 0 is equal to u, these cancel, minus tan a from the sine a over cos a, and I'm going to have tan b. I'm also going to have the 2 in front, and I'm going to have my u. So dividing across by u and bringing the 2 tan a tan b to the left, I'm going to get 2 tan a tan b is equal to 1. So tan a tan b would be equal to a half. So that's shown tan a tan b is equal to a half. Now we're told if b is equal to 30, find tan a and the time of flight in terms of u and g. Well, we have the time of flight there, 2u sine a over g cos b. If b is equal to 30, the tan of b is equal to 1 over root 3. You should know that from your knowledge of your angles. So tan a times 1 over root 3 is equal to 1 over 2. So tan a is equal to root 3 over 2. The time of flight, we need sine a and we need cos b. Well, let's get sine a here. tan of A is opposite over adjacent is going to be the square root of 4 plus 3, which is the square root of 7. So the sine of A is equal to opposite over hypotenuse root 3 over root 7. And then we're told that the tan of, we have the sine of A, we need the cos of B. Well, we have the tan of B is equal to 1 over root 3. The tan of B is 1 over root 3, leaving this one as 2. So the cos of B will have to be equal to A over H, root 3 over 2. So the time of flight then becomes 2u sine A over g cos B, 2u sine A over g cos B is going to be 2u times root 3 over root 7 divided by g times the cos of B, which is root 3 over 2. So we turn it upside down and multiply. The 2 goes there and the root 3g goes here, which would leave me with out this guy on the line, so they cancel. So we're left with 4u over root 7g as the time of flight in terms of u and g.